I'm Kendall Trump with Grain Journal Magazine in Decatur, Illinois. Welcome to Deadline 2022, New Dust Hazard Analysis in NFPA 61 and NFPA 652. This is the 10th in a series of webinars to be presented by GEAPS and Grain Journal Magazine in 2018. In 2016, a new NFPA standard on the Fundamentals of Combustible Dust, was issued. The intent of this standard was to provide the basic information needed to analyze and protect against dust explosions and fires. NFPA 61, Standard for the Prevention of Fires and Dust Explosions in Agricultural and Food Processing Facilities, has been the standard used by the agricultural industry since 1923. The 2017 edition is the most recent, and a new edition will be issued in 2020. NFPA 61 requires a dust hazard analysis to be completed by 2022. Chapter 7 of NFPA 61 provides guidance on how to perform a dust hazard analysis. The dust hazard analysis evaluates the fire and explosion hazards of a facility and gives recommendations to manage these hazards. Today's webinar will focus on the methodology of the dust hazard analysis and the checklist provided in annex material of NFPA 61. We do hope to see you at GEAPS Exchange 2019, which will be held March 9th through 12th, 2019 in New Orleans, Louisiana. Today's webinar is sponsored by M&M Specialty Services. M&M specializes in protecting your people and your products with the best in quality and affordability in personal protection products, grain protectants, fumigants, and services. They are based in Leavenworth, Kansas. Our webinar is also sponsored by VAA LLC, who has provided engineering and design services in the agribusiness industry since its founding in 1978. Working with owners, equipment vendors, and design-build contractors, the firm specializes in bulk commodity handling facilities, including slip-form design, material handling, transportation, and export. They are based in Minneapolis, Minnesota. Our presenter today is Matthew J. Bajeski. Matt launched MJB Risk Consulting in 2005. He was responsible for the coordination and delivery of professional consulting services to his clients. He has significant experience in the design and administration of property loss control programs and process hazard analysis for grain processing and the food industry. Matt received a Bachelor of Chemical Engineering degree at the University of Missouri-Rolla in 1985 and his MBA at the Allen School of Business at Washington University in 2000. He started his career as a loss prevention consultant in the property insurance industry in 1986. Matt is a member of the American Institute of Chemical Engineers, the National Fire Protection Association, and the Society of Fire Protection Engineers. He has previously served as an officer in the local chapter of the SFPE. He is a registered professional engineer and has the ARM designation. He is a current member and the past chairman of the NFPA Committee on Agricultural Dusts. Matt has been on the committee since 1998. In 2013, he became a member of the NFPA Correlating Committee on Combustible Dusts, which oversees all of the NFPA dust documents. Please feel free to ask questions today by typing them into the questions box at the right-hand side of your screen at any time during our webinar. We will be answering your questions during a Q&A session following our presentation. We will begin with a quick polling question today. How many people are viewing at your facility? Thank you for your participation. As a note, today's webinar is being recorded and it will be posted to our website, grainnet.com, within 24 hours. All registrants will also receive an email containing a link to the recording and our presentation slides. At this time, Matt, can you please do a voice check?
Check, check.
Great, we can hear you perfectly. And can you also please show us your screen?
And there it is. Good.
There we go. Ladies and gentlemen, here is Matt Bajeski.
Thank you, Kendall, and good morning, everyone. It's a pleasure to be able to give this presentation. I'd like to thank GEAPS for asking me to participate in it. As Kendall said, I'm a long-term member of the NFPA Agricultural Dust Committee, and I'm still a member. I was a past chairman, and I'm also a member of the Combustible Dust Correlating Committee. So I have a long history of dealing in the agricultural dust industry and with the NFPA standards. So this morning I'm going to speak for about 45 minutes, and then there'll be time for questions at the end. My presentation has two main topics. One is discussing the history of NFPA 652 and NFPA 61. And then the second part of the presentation is to discuss the dust hazard analysis checklist from NFPA 61, which I think is a very good tool and a very good guideline. It gives you an easy way to do a dust hazard analysis. It's not as scary as you might think it is. So I do have an early polling question, just so I can get to know my audience. So are you familiar with or regularly use these NFPA standards, NFPA 61, NFPA 652, both or neither? Wow, okay. Both or neither is equally split. So that's a good spread.
Matt, you can let me know when you'd like me to close the poll.
Oh, you can close the poll. It's just like the election. Equally split, both or neither. So any discussion on 652 really starts with the Imperial sugar explosion in February 2008. NFPA 652 is a brand new standard. And the Imperial sugar explosion in February 2008 was kind of a watershed event as far as changing the NFPA standards. And there would not be an NFPA 652, in my opinion, if it wasn't for this explosion. So the Imperial sugar explosion, 14 killed, 36 injured. It was a major event. I was in Australia at the time, and I heard about it all the way in Australia because it was on the news everywhere. So I'd like to talk about the Imperial sugar explosion a little bit at first. So these are two pictures of the aftermath of the explosion and fire. The key takeaways were, number one, poor housekeeping, overloaded dust collectors, equipment maintenance, and poor management of change. These causes are very familiar and common for combustible dusts, so not surprising that these would be factors at all. Some of the background on what happened, they had a conveyor system below the silos, and they had recently installed a cover on top of one of the conveyors to prevent contamination. The housekeeping was very poor. Unfortunately, once they covered the conveyor, the dust collector system was not picking up the dust. They had an ignition source, and it exploded. And of course, secondary explosions really caused the most damage. And that was mostly due to poor housekeeping in the remainder of the plant. Once you have an explosion, it puts other dust up into the air, and it causes more explosions. So containment of the dust is really what resulted in the initial explosion. So as a result of that, there was a major investigation. The Chemical Safety Board came in and did its investigation, and they had a number of recommendations that they made. Both to OSHA and to NFPA, other government agencies. During their investigation, there was some confusion over which NFPA documents to use. Technically, sugar falls under NFPA 61, agricultural dust, but some people felt that NFPA 61 wasn't adequate to address what happened at Imperial Sugar. So they were really using some of the other NFPA 654, which is another one of the dust documents, And there's a total of 5 dust documents, and they weren't exactly clear on which ones to use. So there was a lot of criticism of NFPA because it wasn't clear on what they should use. There were congressional hearings, there was a call for more regulation. NFPA actually testified before Congress. And then OSHA, at the urging of the Chemical Safety Board, proposed a new combustible dust rule. So there are some existing OSHA regulations, especially for the grain industry. OSHA 1910 subpart R covers grain handling facilities, but what was recommended was really a more comprehensive rule for the entire food and agricultural industry, and not just food and agricultural, but any industry that handles combustible dust. So OSHA worked on that from 2009 to 2012. There was some pretty heavy discussion about the combustible dust rule. There were hearings. And then in 2012, there was a new election, and Congress was not as concerned about it maybe as they had been in the past, and so it lost some of its steam. And then under the current administration, OSHA has actually withdrawn the proposed combustible dust rule. They said due to resource constraints. So for right now, it's basically dead as far as a new OSHA regulation. But NFPA still felt pressure from OSHA to clarify the combustible dust documents, and so initially there was a major push to combine all of the NFPA dust documents into one big document for combustible dust. But as you can imagine, that's a very, very complicated thing to do when you consider wood dust, metals dust, agricultural dust, plastics dust. There's a lot of different pieces of equipment. There's a lot of industries involved. So the various NFPA committees had a lot of pushback on combining it into one big standard. So finally, it was agreed to form a new standard called the Fundamentals of Combustible Dust, which was NFPA 652. And so this was developed out of a perceived need to provide basic requirements for handling combustible dust. They started work in 2012 and they finished in 2015. As you can imagine, there was a lot of discussions, a lot of changes. The standard was delayed 6 months, I believe, because there were some things that couldn't be agreed upon. But finally, 2016 was the first edition of NFPA 652, and it set a requirement to complete a dust hazard analysis within 3 years of the effective date of the standard, and that would have been 2019. So 652 was a very new document. Not a lot of people were aware of it. Our poll today, 38% of the people were aware of both NFPA 61 and 652, so that's a pretty good number. But the standard is revised every 3 years, and so the 2019 edition of NFPA 652 set a date of September the 7th, 2020 to complete the dust hazard analysis. So it slipped a little bit from the original date of 2019, but instead of having just saying 3 years, it had a hard date of September 7th, 2020. And then it also requires a dust hazard analysis to be reviewed and updated every 5 years. So then we moved to NFPA 61, which is the standard for prevention of fires and dust explosions in agricultural and food processing facilities. This NFPA standard, the original version, was adopted in 1923 for grain terminals and flour mills. And the modern version really was adopted in 1995 when several of the agricultural dust documents, including sugar, were combined into one document for the agricultural and food processing industries. So NFPA 61 is applicable to all facilities that receive, handle, process, dry, blend, use, mill, package, store, or ship agricultural bulk materials, their byproducts, dusts, grains, oil seeds, agricultural seeds, etc. It's sugar, flour, etc. So for GEAPS members, NFPA 61 is the standard that you would fall under. Also applicable to all facilities designed for manufacturing and handling starch, drying, grinding, conveying, processing, etc. The only thing it really doesn't apply to is what's covered by NFPA 36, which is the oil seed extraction standard for soybean processing, really. So there's 30 members on the committee for NFPA 61. The agricultural industry is represented by Ag Processing, AFIA, Ardent Mills, Cargill, General Mills, GEAPS, and the National Grain and Feed Association. And NFPA 61 says that the dust hazard analysis is required by 2022. So which one do you use? 652 says by 2020, September 7th, and NFPA 61 says by 2022. So there is a conflict section in NFPA 61, and it's in all the dust hazard standards now, and they pretty much say the same thing. It says where requirements specified in this industry-specific standard, meaning NFPA 61, differs from a requirement specified in 652, the requirement in this standard, NFPA 61, shall be permitted to be used instead. So basically what this says is that NFPA 61 takes precedence over NFPA 652. Or it says where a requirement specified in the standard specifically prohibits requirements specified in 652, the prohibition in this standard shall be permitted. And then it was also added, the requirements of the standard shall be applied or construed as to not create an unreasonable risk to public food safety. So the NFPA 61 is unique from the other combustible dust standards because it does involve food and food safety. So we added that one as far to just to make it clear so that this would not conflict with NFPA 652. And to handle any conflicts and provide a common framework for the dust documents, a correlating committee was formed in 2012, 2013. So the correlating committee on combustible dusts for NFPA oversees all of the dust documents, including NFPA 61, there's 484 for combustible metals, there's 652 Fundamentals of Combustible Dust. There's 654, which is combustible particulate solids, which originally back in the 50s when it was first started, it was really for the chemical industry dealing with plastic dusts and things like that. There's 655 for sulfur fires and explosions, and then there's 664 for woodworking facilities. There's currently 14 members on the correlating committee. And Cargill is really the only grain industry representative on the committee. Right now, each of these documents is on a 3-year cycle, and that was, some of them were originally on 5-year cycles for revision. NFPA 61 was a 5-year cycle document, but because of all the changes with 652 and the changes in 61, all the documents were moved to a 3-year cycle. So they're currently on 3 years, but now that some of the dust is settled for the changes in 652, we might be changing some of them back to 4 or 5-year cycles. That's kind of in flux right now, and it's up to the committee itself to determine how often they want to meet. So one of the differences in the dust hazard analysis is that it is retroactive. So normally the requirements in NFPA standards are not retroactive unless it specifically says they are. And in that case, if it's not retroactive, the facility would only need to be upgraded to the current standard if there are major modifications or new processes, et cetera. But the dust hazard analysis is retroactive, and by retroactive, they mean it's required for new construction or significant modifications that exceed 25% of the replacement cost of the equipment. So it is something that should be done and should be done by the deadline if you want to follow NFPA 61 or 652. So my next polling question is, what documents do you follow to perform a dust hazard analysis at your grain handling facility? And Kendall tells me there was a problem with loading the polling question into her computer system. So if you could just write down your answer, and then I'll give you the answer in 10 seconds. So the answer to the question really is somewhat of a trick question. NFPA 61 is what I would use as an agricultural or grain handling facility. However, you could use NFPA 652 because in NFPA 61, really, if you comply with anything in NFPA 652, it's going to be acceptable in NFPA 61. So answers A, B, or C would be acceptable for this answer. So the next question is there a need for a dust hazard analysis? So one of the earliest and largest and most famous dust explosions was in Minneapolis at the Washburn A mill in 1878. At the time, it was the largest flour mill in the world, and it resulted in 18 people dying from the explosion and the ensuing fire. It could have been worse, but it happened on the night shift, so that was fortunate. And right now it's been turned into a museum. If you ever go to Minneapolis, the Mill City Museum, it's a great museum. I went there last year, and it really shows you how a mill works, what the issues were with the dust explosion, and I'd highly recommend it if you visit Minneapolis. So moving ahead, 100 years later, Oswego, Louisiana, 1977. That's the picture that's in this slide. Grain elevator explosion, 36 people died. So it was a pretty horrific explosion, and it brought around some changes to NFPA requirements after that explosion. More recently, last year, Cambria, Wisconsin, and Northrop, Minnesota. And then this year, South Sioux City, Nebraska, and Crystal City, Manitoba also had dust explosions, fires. So even though we've had agricultural dust requirements since 1923, we continue to have dust explosions and flash fires from dust. And so many people believe that it could have been prevented by following the existing prescriptive requirements in NFPA 61. But there's a lot of people that also felt that the profile of these dust explosions needed to be raised. And that was really one reason why the new standards require a dust hazard analysis, because the committees felt that requiring a dust hazard analysis would put a new focus on the dust explosion potential at these facilities. So that's where we are today. So then the question is, okay, who's in charge? Is OSHA in charge of requiring you to do a dust hazard analysis? Right now they're not. If you have an event and OSHA comes in and does an investigation, you'll certainly be fined if you didn't follow NFPA standards or do a dust hazard analysis. But obviously, if there is an event, something went wrong and likely to be fined anyway. So is the local fire marshal or building code official in charge? Well, it could be, depending on the laws of your jurisdiction. NFPA, are they in charge? NFPA is not in charge of anything. They have no authority whatsoever. They're a nonprofit organization that writes the codes, or it depends on the committee to write the codes. So going back to the local fire marshal or building code official, local fire codes and building codes can adopt NFPA standards. So if your local jurisdiction has adopted an NFPA standard like NFPA 61 or NFPA 62, then it could be required by law to complete a dust hazard analysis. But as far as I know, nobody has adopted NFPA 652 yet. It's too new, and building codes and don't change very quickly, and lots of times they're also subject to politics. So I would check your local jurisdiction to determine if it's required by law to do a dust hazard analysis and follow NFPA 61 or NFPA 652. And then finally, there's the insurance company. The insurance companies follow NFPA standards for the most part, but they have no legal authority to enforce it. So you can follow the insurance company requirement or not, and of course the insurance company can cancel your insurance if if they don't think that you're doing a good job in managing the risk. So technically, you're not legally required to perform a dust hazard analysis, but if there is an incident, the government or if somebody, or the plaintiff attorneys, if somebody gets killed or hurt, they're going to be asking, why didn't you follow the standards? So if you want to do it, NFPA 61 provides a good framework for performing a dust hazard analysis. So the purpose of the dust hazard analysis is to identify the hazards in the process and document how those hazards are being managed. The hazards addressed are basically fire and explosion hazards from combustible dusts. So we have very minimal prescriptive requirements in Chapter 7. Chapter 7 covers the dust hazard analysis. So there's really only 3 sections, and they're very short. In Chapter 7, one is responsibility for doing the dust hazard analysis, the criteria for doing the dust hazard analysis, and then how you do with the dust hazard analysis, the methodology. So the responsibility and criteria, for right now, the owner-operator is the responsible person to ensure the dust hazard analysis is completed. So as I said earlier, it's not a government requirement unless your local jurisdiction has adopted these standards. So for right now, it's voluntary, and the owner-operator is responsible for it. The dust hazard analysis shall evaluate the fire, the deflagration, and explosion hazards and provide recommendations to manage these hazards. The dust hazard analysis shall also be performed or led by a qualified person. And I have a slide on what a qualified person would be. And the results of the DHA review shall be documented, including any necessary action items requiring change to the process, the physical process, the operations, or the facilities associated with the process. So it has a pretty broad range. And for major large plants, it can be quite complicated, but for smaller country grain elevators, it's really not, shouldn't be a difficult process. So the next slide. So who is a qualified person? The qualified person who's leading or performing the DHA should be familiar with conducting a DHA and the hazards of combustible dusts. So yes, it's always helpful if the person is familiar with the hazard. Usually you'll have a team perform a DHA. The team could be made up of a variety of persons, operations, maintenance people, process engineering, safety professionals, consultants. They should be familiar with the process, and hopefully people at the actual facility or plant would also participate in the dust hazard analysis because they know their plants better than anyone else. So that would be considered a qualified person. The methodology that you would use, this is in Chapter 7. So these are the basic requirements that the process has to meet to be considered an adequate dust hazard analysis. So identification and evaluation of the process or facility areas where fire, flash fire, and explosion hazards exist. And then where they do exist, identification and evaluation of the specific fire and deflagration scenarios shall include the following. 1, identification of the safe operating ranges, meaning basically the ranges of the equipment, what's the explosive range of the combustible dust. Identifying the safeguards that are in place to manage the fire, deflagration, and explosion events. And then also recommendations for additional safeguards where warranted, including a plan for implementation. And the DHA shall be based on data obtained in accordance with Chapter 5 for material that is representative of the dust present. So lots of times dust will be mixtures of various things. You have various size flakes in the dust, you have different types of dust, you have contamination in the dust. Sometimes you even have metals in the dust. So it should be representative of the actual dust that you have at your site. So how do you know if you have a combustible dust? So we go to Chapter 5. So Chapter 5 says that the owner-operator shall be permitted to either assume the dust is combustible, or you can determine the combustibility if you don't think the dust is combustible. So in order to determine the combustibility, you can use historical or published data that is representative of the current conditions. There's a large annex material in NFPA 61 that provides information on various types of agricultural and food dusts that provides very good data, but always remember it is a range of data, and conditions can be different depending on how you're processing and making the dust. Moisture content has a huge impact on whether the dust is explosive or not. So you can analyze a representative sample rather than using the published data, or the samples can be tested using the ASTM E1226 standard test method for explosivity of dust clouds, or they could also be tested using the ASTM E1515 standard test method for minimal explosive concentration of combustible dust. Those are long titles for very, very complicated testing. And there are testing labs that you can send a sample to, and they can perform those tests for you, and you get back results. Or you can use an equivalent testing methodology. NFPA is written for the international market, and so some other countries, or the European Union, for example, might use different test methods to determine if something is combustible or not. So NFPA always throws in something like using equivalent testing methodology. So once you know that you have a combustible dust, then you have to determine, okay, will the combustible dust explode? So how do you know it's going to explode? A deflagration is a propagation of a combustion zone at a velocity that is less than the speed of sound and in the unreacted medium. So most agricultural dust explosions are going to be deflagrations, as opposed to a detonation, which is velocity faster than the speed of sound. And these are usually gas explosions, flammable liquids that form into a gas, things like that can be detonated. So the dust hazard analysis should consider 4 conditions that are required for deflagration. A combustible particulate solid or sufficiently small particle size to deflagrate. So the key words here are sufficiently small particle size. In some of your processes, you might have large flakes. Flakes are not going to explode per se, but flakes could give off some, fine-grained particles, some dust that could have a sufficiently small particle size to explode. 2, combustible particulate solid suspended in air to deflagrate, or other oxidizing medium. So again, the key word here is suspended in air. So number 1 was a small particle size. Number 2, suspended in air. Number 3, a combustion particulate solid suspension of sufficiently high concentration to deflagrate. So here the key words are sufficiently high concentration of dust. So we have small particle size, we have suspended in air, it's sufficiently high concentration, so meaning it's in the explosive zone. And then lastly, we need some method of igniting the dust cloud to have an explosion of deflagration. So these are the 4 things that are required in order to have a dust explosion. And graphically, this is represented. This is also from Chapter 5 in NFPA 61. So we have the basic fire triangle in the middle. We have fuel, we have oxygen, and we need an ignition source to cause a fire. And lots of people are familiar with the fire triangle. But we expand that when we're talking about dust. So on the right-hand side, for a flash fire involving dust, you also need dispersion of the dust. So you need a dust cloud. And if you have a fire and a dust cloud, or a dust cloud that's not big enough to be in its explosive zone, you can still have a flash fire. And then finally, in order to have an explosion, besides having the fire and the dispersion into a cloud, you also need confinement. If it's in open air and you have a cloud, it's more likely to be a flash fire. It's not going to be an explosion because there's no confinement of that dust. I'm talking about outside. But once you put it inside, in a building, in a container, in an enclosed conveyor, it's confined and it could explode. So my next polling question, again, the polling is not working right now, but so fuel and an ignition source and an oxidant are required for fire. What additional items are required for an explosion? A, dispersion of the dust, but no enclosure. B, dispersion of the dust in an enclosure. C, no dispersion of the dust in an enclosure. Or D, none of the above. So you can write down your answer for that. And the answer, of course, is B, dispersion of the dust in an enclosure, as was shown in the triangle and the diagram. So once we've determined that you do have an explosible dust and you do have conditions that could cause an explosion, what methods do we want to use to perform a dust hazard analysis? So we perform a dust hazard analysis to evaluate the hazards and provide recommendations to manage these hazards. And there's several possible methods to do this. One is a checklist, which NFPA 61 has an example checklist in the annex material. You could do a what-if analysis, failure mode and effects analysis, fault tree analysis, HAZOP study. So there's many ways to do a dust hazard analysis, and there's no one specific requirement on how to do it. It just has to include those items that I listed on the earlier slides. And additional guidance on performing a DHA is available in NFPA Guide to Combustible Dust and in the AICHE Guidelines for Hazard Evaluation Procedures. So the rest of the presentation is briefly discussing the different topics covered by the checklist in the annex material of NFPA 61. So there's 14 topics that are covered, and the first one is employee training. So employees should be made aware of combustible dust hazards for sure. So that's one of the first questions in the checklist. Are the employees made aware of combustible dust hazards? Are they trained properly to include housekeeping and cleaning equipment, maintenance, safety critical devices, hot work? Does the combustible dust hazard identification procedures in place? Do you have those so that you can easily identify where there are dust hazards, so the employees can easily identify dust hazards around the plant? And then also very key are the contractors trained in the dust hazards present in the facility. Many times fires and explosions are caused by contractors. The people at the plant do a very good job, have a very good safety program, but then contractors will come in and either they don't follow the rules or they don't know the rules, and they're just not adequately trained on the dust hazards. So the second topic is housekeeping. Of course, housekeeping is extremely critical in reducing dust explosions, and especially the secondary dust explosions from propagating across the plant. So you should have written housekeeping and inspection procedures to make sure housekeeping is maintained. Does the housekeeping program address the high priority areas, such as floors within 35 feet of bucket elevators? Those are good areas to have spills. Areas around grinding equipment, dryers, any equipment that is going to produce heat or sparks. Dust accumulations in the building should be maintained below acceptable limits. An example, an eighth of an inch is often cited is an acceptable limit. So again, dust accumulations on buildings and ledges and beams. If you do have an initial explosion, dust accumulation on the building is just going to propagate it into a secondary explosion. So very important for housekeeping in those other areas. Also, when you are cleaning, using compressed air to blow down areas is not permitted until all the ignition sources have been de-energized, because you don't want to cause a dust explosion by trying to clean up the dust to prevent a dust explosion. And then also storage of combustible and flammable liquids and gases should be separated from any processes that are handling combustible dust. The next section is preventive maintenance. You should have a formal preventive maintenance program for dust handling, producing and processing equipment that specifically includes verification of grounding and bonding. If you have explosion venting, it should be inspected and maintained in accordance with NFPA 68, which is the explosion venting standard. Critical safety systems should be tested annually. Bearings should be maintained. Bearings are a very good source of heat and a very good ignition source for dust fires and dust explosions. And then, of course, records should be kept of the preventive maintenance so that you can show and track the type of maintenance for each equipment. So the next section is dry solid product movement and storage, kind of a strange title, but that's what it is. So do receiving systems have a means to remove tramp metal before the elevator leg or processing equipment? So processing equipment such as hammer mills, if there's tramp metal in the grain stream and you get to a hammer mill and the hammer mill causes a spark with the tramp metal, that of course can cause a fire or explosion. Also, trucks and rail cars that are delivering grain products should be grounded and bonded, especially with the flexible connections. Is the process dust tight? Where explosion venting is used, is there a record of the vent design basis and the flame ball trajectory verified as safe? So when you do have explosion venting, you want to make sure that the area in front of the explosion vent is free from catwalks or walkways, or areas where people would normally be located. It should be pointed in a direction that's, for 99% of the time, nobody's going to be there, and it's a safe area. And the distance too. A flame ball can shoot for a very long distance, 35, 50 feet, for a major explosion. And our process connections isolated to prevent propagation of the dust explosion. So when you have dust collectors, or you have grinding equipment, or conveyor systems, bucket elevators, do you have any isolation to prevent a fire or explosion starting in one piece of equipment from propagating to additional pieces of equipment? So the next section is on receiving and storage. Elevator legs, or the leg casing, head and boot systems dust tight. You don't want a lot of fugitive dust floating around. Bearings should be mounted externally. Internal bearings are very much a source of heat that could cause explosion, and they're also very hard to clean and maintain when they're internal. So bearings should be mounted externally on bucket elevators. Our head and boot sections provided in inspection openings to allow for a clean out and inspect the belt tracking, the lagging and discharge. Again, housekeeping, you need to have areas where you can look inside and make sure that everything is clean, and inspected on a regular basis, that the belt is in good condition. The elevator legs should be protected with explosion venting. This has been a requirement in NFPA 61 for a very long time. And also a requirement in 61 now is that elevator legs should be outside. Certainly if they're inside, they should have explosion venting, or there's also flameless venting, which is a relatively new invention in the last 10, 15 years, and it's gained pretty widespread acceptance now. So I would encourage you to look at flameless venting also. And then also, do all elevators have hazard monitoring, such as bearing temperature, slip switches, belt alignments, things like that. So that was for bucket elevators, but we also have regular conveyor systems, and for some facilities, receiving and storage. So for a regular conveyor belt, rubber belt, the belt should be static conductive, oil resistant, and fire retardant is preferable. Bearing temperature should be provided, and the conveyor belt should be interlocked to shut down. Sometimes we miss this. Lots of times bucket elevators will have the bearing temperature provided, but ordinary belt conveyors also should have bearing temperature, because it's a good source of ignition. And for the Imperial sugar explosion, it was likely that a hot bearing is what caused the explosion. So bearing temperature is very important for ordinary conveyor systems. So do you have emergency stop buttons? Are they tested regularly? Do you have flippers, plows, and wipers installed, and are they functioning properly? You should also have an inspection program for conveyor covers to reduce fugitive dust. Sometimes people take off a cover to make an inspection, or there's a blockage and they'll take a cover off and then they won't put a cover back on. So you should have an inspection program to make sure that the covers are maintained if they're supposed to be there. So the next section would be electrical. Electrical can be a source of ignition for a dust explosion or fire. So you should have an electrical survey to identify areas that may need Class 2 Division 1 or Class 2 Division 2 electrics. So Class 2 is for dust. Division 1 is for areas where dust is in suspension in an explosive concentration for most of the time. Division 2 locations would be areas where if there's a process upset or something else happened to cause a combustible dust cloud, but it's not an ordinary normal circumstance in the plant. So Class 2 again is dust. Division 1 is for potential for dust explosion all the time. Division 2 is for potential for dust explosion occasionally, or if there's a process upset. So does the electrical equipment and wiring in an area meet the requirements of the hazard classification? This should also be checked. Do you have a management of change procedure to maintain the electrical classification? MCC rooms should be pressurized or sealed from fugitive dust. And MCC rooms have a lot of electrical equipment and a source of ignition for a dust cloud. And then also as part of the preventive maintenance program, infrared testing is a good idea to be done on electrical equipment to detect hot spots that could start a dust fire. The next topic in the checklist is dust filter systems. So dust collectors should preferably be located outside. Certainly large dust collectors should be located outside. I know that, for a lot of industries, there's small dust collectors located next to pieces of equipment. I'm talking very small dust collectors. But if you do have an inside dust collector, it should be protected by explosion suppression system, or flameless venting is also a good option. And then you should also have pressure gauges and alarms for the dust collection system to indicate any blockage. Dust should not normally be returned directly to the elevator leg. It should be run through a dust collector. Are the ducts isolated to prevent propagation of a dust explosion? So again, you might want to, depending on how other things are protected, you might want to isolate dust collectors or grinding equipment or other types of equipment where you could have an explosion that would propagate to other pieces of equipment. And then also, is there a change schedule for the dust collector bags or whatever other filter media that you're using? So the next topic is on grain processing. So do you have hammer mills or other processing equipment that could produce a spark? Having a spark detection system is a good idea. It's not required, but it certainly helps to shut down the equipment if you do detect a spark. Are magnets or other means provided to remove tramp metal upstream of hammer mills or other grinding equipment? The equipment should be grounded and bonded. For screw and drag conveyors, they normally should be fully enclosed and designed to stop if there's a discharge, if the discharge becomes plugged. And then also, is processing equipment adequately sealed to reduce fugitive dust? Grain dryers, you know, some people may have these, others don't. But the dryer, so if you don't have a grain dryer, obviously you can skip this section of the checklist. But for people who have grain dryers, they should have high temperature interlocks to shut down the burners and the fans and the product flowing into the dryer and out of the dryer. You should have level alarms, shutdown interlocks, fire suppression system. A sprinkler system is preferable in a dryer. There's been many dryer fires that usually don't result in an explosion, which is good because of the, you know, everything is wet in a dryer. But they are pretty prevalent as far as having fires inside the dryer. You should have documented operating procedures for startup, shutdown, normal operation, power failure, cleaning, inspection of the critical safety systems. You should have a procedure or capability to remove any burning grain from the dryer, like, for example, an emergency dump, because once you have the fire inside the dryer, it's preferable to remove the grain from the dryer, and so you can extinguish the grain once it's outside. Hazard monitoring and alarms. You should have critical hazard monitoring devices tied into an audible system for the plant control room, or like a startup alarm, things like that. That's a plant-wide alarm. The alarm systems also should be tested regularly and records should be kept. Do you have a history of any problems with the hazard monitoring devices? It's always good to document that and correct the problem. And are procedures established to take appropriate action if you do have a critical hazard monitoring device that's bypassed? Sometimes you need to do that. Sometimes for maintenance purposes or whatever, you need to bypass a critical piece of hazard monitoring equipment, but you should have a procedure in place to put that back in service as quickly as possible and to notify the appropriate people that you are bypassing a critical hazard monitoring device. Emergency response is, of course, important, and especially for grain combustible dust fires and explosion hazards. A lot of local fire departments may not be familiar with the hazard, and I've heard stories of lots of volunteer firemen and even full-time firemen getting injured from doing the wrong thing when they're fighting a fire involving a silo that has combustible dusts. So does your emergency response plan have specific procedures for the grain bin and silo fires? And is the local fire department aware of firefighting procedures for grain fires and potential dust explosions? You're relying on them to fight that fire and put it out, and it's a good idea to invite the fire department on a regular basis so they are familiar with the hazards. And, you know, talk to them, ask them, what would you do? How would you fight this fire? Some of them might say they're not going to fight the fire. So you want to establish a perimeter of how far away you should be in case you do have a dust explosion in a silo. And then also hoses are required by NFPA 61 and for grain silos. And also, is there adequate means of egress from the top of the elevator or silos and tunnels? Very important for employees, and then also very important to allow the fire department to get in to fight the fire. So we are in the middle of revising NFPA 61 right now. Our next meeting is in January in Phoenix, if anyone would like to attend. Guests are welcome. But as far as the annex is concerned, some of the additions being considered for the checklist for the 2020 edition are materials evaluation, building and facility design, ignition source control. The section is being added for marine towers, recycling of filtered air, and then also heat transfer systems such as steam systems that are used for heat transfer. So I didn't include this in the presentation because it hasn't been adopted yet. It's been proposed. And so like I said, when we have our meeting in January, it'll probably be adopted. So you'll have additional information in the 2020 edition of NFPA 61 in the annex to help you do a dust hazard analysis for your facility. So those are the basics of the dust hazard analysis. And so the results of the dust hazard analysis, of course, should be documented. And the documentation should include any action items requiring change to the process materials. Also any action items requiring a change to the physical process. And are there any action items requiring change to the operations or facilities associated with the process? So all of this should be documented as a result of the dust hazard analysis. And as part of the documentation, the NFPA 61 says you should also include, but not be limited to, test reports, drawings, sizing calculations for explosion venting. It's important to document things not only so that future changes for the process engineers have an idea of what you did in the past and can work on that and whatever modifications they have, but also any government agencies or insurance companies might want to review the dust hazard analysis. And so it's good to have good documentation of everything that you did. You don't want to spend a lot of time doing a lot of hard work and then not write it down and keep it in a safe place. So that's my presentation, and I guess we'll open it up to questions.
Hi, Matt. I apologize about the brief delay there. We will now begin our Q&A session. If you have not yet submitted your questions, please do so at this time. Okay, Matt, our first question today. Where in NFPA 61 does it state that the DHA is required by 2020?
The current NFPA 61, I'd have to look that up. Yeah, I don't remember exactly which paragraph it says that. I would have to look it up.
Sure. If you'd like, I can send this question forward to you and you can do the research.
Well, it says for a 5-year period from the effective date of this standard. So 7.1.2.2 says that the dust hazard analysis should be done in a 5-year period. So this is a 2017 edition, so 2022 would be 5 years. And in the new edition of 61, I'm pretty sure we're going to put a specific date on when it needs to be completed, such as the end of 2022.
Okay, next. What are typical costs for lab testing of dusts?
Oh, that's a really good question. And I have not done any testing of dusts, so I don't have an answer for that. That's a very good question. I guess it depends on exactly what testing you want done, what the dust sample is. Yeah, I don't have any idea. It's not, I don't think it's exorbitant.
Okay, our next question. Does the grain handling standard cover NFPA 61?
Does the grain handling standard cover NFPA 61? Which, I don't understand the question. Which grain handling standard?
I believe the OSHA grain handling standard.
No, I don't believe it specifically references NFPA 61. The OSHA standard, subpart R, 1910 subpart R, there's a standard 1910-272 for grain handling facilities. But I don't know that it specifically references NFPA 61, but of course, if there's an incident, OSHA is going to pull out whatever standards there are, even if it's not a regulation. They're going to bring out standards, and based on the general duty clause, they can cite just about anything that they want. So NFPA 61 would be the standard for agricultural industry.
Okay, thank you. Our next question. With what we know about corn, soybeans, and wheat dusts, is it safe for general industry to just assume that dusts are combustible versus submitting samples for testing with associated costs?
Yes, I would assume it's safe to just assume that it is combustible. Now, if you have something that has a very high moisture content that really doesn't get dried out, then you could send that as a sample. It's probably not going to explode, but eventually, at some point along the process, it's probably going to be dried out and dry enough to be in the explosive range.
Okay, our next question. Are explosion vents required for bucket elevator heads as well?
NFPA 61 has a diagram that shows exactly where you need explosion venting in bucket elevators. And it does require the head section to have explosion venting on the top surface, and then also on the side of the head to deflect any type of explosion upward. So yes, it is required.
Okay, our next question. Are there discussions to distinguish the need for pressurization between Division 1 areas from Division 2 areas?
Can you repeat the question?
Sure. Are there discussions to distinguish the need for pressurization between Division 1 areas from Division 2 areas?
No, we're not having any current discussions on that, on pressurization. Nope.
Okay.
Not as a requirement.
Our next question. How does NFPA 61 view enclosed belt conveyors and drag conveyors? They typically have a volume greater than 8 cubic feet, but don't seem to typically have venting or suppression systems.
Well, that's a very technical question. Conveyor systems should usually have dust collectors attached to them. Covered conveyors would normally have a dust collection system and a transfer point, and that should keep the dust concentration below the explosive range in a covered conveyor. I would certainly recommend having covered conveyors because it reduces fugitive dust, but no, explosion venting is not required on covered conveyors.
Okay. In general, do most building codes that adopt NFPA standards also require compliance with NFPA combustible dust standards?
That is a huge question, and I would say no. Lots of times jurisdictions there's very few jurisdictions, states or cities that adopt the entire NFPA standards, all the NFPA standards. There's very few areas that would actually do that. Usually it's adopted, building codes are adopted, or individual NFPA standards are adopted. So for agricultural states, some states may have adopted NFPA 61. I don't have a list of states that would have adopted them. But I would say for the most part, it's not been adopted into law. But again, if there's an incident, OSHA or government agent, any other government agencies, plaintiff attorneys, they're going to cite NFPA standards as saying you should have complied with this, and if you had complied with it, you wouldn't have had this situation. So, so legally, it's probably not required, but certainly there's a reason to do it.
Thank you so much. I apologize that this is all the time that we have for questions today. Thank you all for your participation. If your question was not answered, I realize we have several questions that have come through, then it will be sent forward to our presenter. That is all that we have for today. I want to go ahead and thank our sponsors, M&M Specialty Services and VAA LLC, for their support in bringing you today's webinar. And I also want to thank GEAPS and our presenter, Matthew Bajeski, for joining us today and for answering these questions. As a reminder, thank you so much. As a reminder, this webinar has been recorded and it will be available for viewing on grainnet.com within 24 hours. All registrants will also receive an email containing a link to our recording and our presentation slides. Our next GEAPS webinar will be held on Tuesday, December 4th at 2 p.m. Central Time. We will be discussing employee motivation and engagement and safety, to be presented by Chris Goulart of Aon. I want to thank you all again for attending and wish you all a great day.